These insane construction projects prove that China is 100 years ahead, and US engineers are shocked. You think you understand what's possible in construction. You don't. What you're about to see isn't theory or concept art. These are real structures, standing right now, built with techniques that make traditional engineering look like Stone Age technology. 15 projects that redefine what humans can build. And we're starting with something that sounds impossible. Imagine printing an entire park out of garbage. AICT 3D Printed Park. The world's first 3D printed park built from construction waste. Shanghai's AICT Park fed demolished building materials into massive printers that layered recycled aggregate into permanent structures. Benches, bridges, pavilions, all printed on-site. Traditional parks take months. The printers extrude material that hardens as it builds, creating structures stronger than conventional concrete because the layering compresses everything. What normally takes 6 months happened in 72 hours. They turned demolished buildings into infrastructure without trucks, without waste, without the carbon footprint. But printing a park is nothing compared to moving an entire neighborhood. Huayanli Shikumen, complex relocation. 7,600 tons of historical buildings. Engineers didn't demolish the Huayanli Shikumen complex. They picked it up and moved it. Multiple connected structures, centuries old, fragile. One crack and the entire complex crumbles. Engineers threaded steel beams underneath without disturbing the buildings above. They lifted everything onto synchronized hydraulic jacks. Every jack had to lift at exactly the same rate, within millimeters. They moved it 288 feet over 11 days. Not a single window cracked. They relocated history itself. Fosun Foundation Cultural Center, 3,200 bronze curtains that move independently. The Fosun Foundation is wrapped in panels controlled by individual motors. Each curtain adjusts based on sun, temperature, and wind. Thousands of moving parts on a building exterior. Wind loads change constantly. Temperature makes metal expand. One malfunction and the facade tears apart. The control system coordinates every curtain in real time. The building transforms from solid bronze wall to transparent veil in minutes. Architecture that moves like living tissue. Then came a building with bamboo at impossible scale. Anji Culture and Art Center. Bamboo as primary structural material for a massive building complex. Not decorative cladding, load-bearing architecture. Bamboo's strength varies by section and expands with humidity. Traditional calculations don't work. Engineers developed a tension cable system running through the bamboo framework. The cables compensate for flexibility, turning organic poles into rigid geometry. They tested each section individually and adjusted cable tension accordingly. Sustainable materials without compromising on span or stability. But nature is nothing compared to defying gravity completely. Sunrise Kempinski Hotel. A horseshoe hotel cantilevering over a cliff with guest rooms suspended above empty air, floor-to-ceiling glass, where solid rock should be. Every room hangs in space. Cantilevers extending dozens of feet beyond supports. Wind hits from multiple directions. Glass adds tons to sections already hanging over nothing. Engineers drilled massive anchor bolts deep into bedrock. A steel exoskeleton transfers cantilever weight back into the mountain. The building doesn't sit on the cliff. It grabs onto it. That's nothing compared to eliminating support columns entirely. Kuju Sports Park and Stadium. 30,000 seats with 0 interior columns. The roof spans hundreds of feet with nothing blocking sightlines. The roof alone weighs thousands of tons. Spanning this distance means the roof must support itself across empty air. Engineers used tensegrity structure. Steel cables pull inward while compression struts push outward, creating self-supporting web. The outer ring carries all load to perimeter supports. Physics turned into balance. But even that can't compare to building downward. Intercontinental Shanghai Wonderland. A 5-star hotel descending 292 feet below ground into an abandoned quarry, 16 stories below the surface with underwater rooms. A waterfall cascades past windows. Building in a hole that wants to flood. Groundwater seeps continuously. Quarry walls could collapse. They built a waterproof concrete shell against the walls. Continuous dewatering pumps run 24/7. The underwater floors use aquarium-grade pressure-resistant glass. They built the waterfall into the drainage system. The entire hotel is a submarine in a pit. Then engineers decided even that wasn't fast enough. Mini Sky City, 57 stories in 19 days, 3 floors per day. A complete skyscraper with plumbing, electrical, HVAC, and finishes in under 3 weeks. At 3 floors per day, there's zero room for error. Engineers built entire floor sections in factories with utilities pre-installed. On site, cranes stacked modules like blocks. The modules interlocked with steel connectors that bolted in minutes. They eliminated 90% of on-site construction. It's not construction, it's assembly. But speed is meaningless if you can't defy physics. The CCTV headquarters. 2 towers leaning toward each other, connecting with a 473-foot horizontal section in the air. The building bends 90 degrees twice, a skyscraper that rejected right angles. As they built upward, the lean increased. The towers had to meet at exactly the right point. Miss by inches and it fails. Both towers fighting to topple the whole time. Engineers installed massive steel trusses, holding them stable. The horizontal section built from both ends simultaneously. When they joined, they removed the temporary supports. The loop holds itself up through continuous tension. Yet even bending skyscrapers can't match fighting typhoons. Ping and Finance Center, 1,965 feet tall, wind speeds exceeding 100 miles per hour. The Ping An Finance Center rises into typhoons that try to shake it apart. The higher you go, the harder physics pushes back. Wind creates vortexes, causing dangerous sway. Engineers installed a 600-ton tuned mass damper near the top, a massive pendulum that swings opposite to wind direction. When wind pushes the building one way, the damper counteracts it in real time, fighting physics with physics. But fighting nature is nothing compared to bending reality. Shenzhen Science and Technology Museum. A 400-foot diameter sphere covered in seamless curved glass. One continuous surface with no joints, no seams. Impossible geometry made real. Glass doesn't naturally curve at this scale. Every panel must fit perfectly. They developed custom forming for mega-scale curved glass, heated to precise temperatures and shaped using gravity. Laser measurements ensured millimeter precision. The geodesic framework distributes load through geometry. A building that looks like it shouldn't exist. Then came the moment when speed meant life or death. Huashanshan and Lishanshan hospitals. 2 complete hospitals, 2,600 beds, 10 days. Functional medical facilities with isolation wards, intensive care, full utilities, operational hospitals where empty land stood. People were dying. Every hour mattered. These needed negative pressure rooms, medical gas, waste treatment, advanced HVAC. 7,000 workers in 24-hour shifts. Prefabricated rooms arrived on trucks. They assembled modules and connected utilities simultaneously. Foundations, structures, systems, and testing happened in parallel. Desperation created focus. But that was just the beginning of impossible scale. Beijing Daxing International Airport, 7.5 million square feet under one roof. Largest single building airport on Earth. Built in less than 5 years. 100 million annual passengers through this space. The roof spans massive distances with no internal columns. They used a steel lattice network acting as both structure and ceiling. Load distributes across the entire span through geometric precision. 8 piers radiate from center. The furthest gate is 8 minutes from security. They made massive feel intimate. Then they connected 3 cities across open ocean. Hong Kong, Zhuhai Macau Bridge, 34 miles across the Pearl River Delta. Bridge that becomes underwater tunnel where cargo ships pass overhead, then becomes bridge again, through one of the world's busiest shipping lanes. Building in open ocean with typhoons and earthquakes. Tunnel sections placed underwater with millimeter precision. They built 4 artificial islands as tunnel portals. Tunnel sections weighing 80,000 tons floated into position, then flooded to sink precisely. Divers guided each section using GPS. Bridge sections use flexible joints for typhoon movement. Designed for 120 years in brutal conditions. But even that pales compared to the structure that changed Earth itself. Three Gorges Dam, the largest hydroelectric dam on Earth, 7,660 feet long, 600 feet high, controls the Yangtze River and powers 60 million homes. Geological transformation, 27 million cubic yards of concrete, reservoir 400 miles long. One failure and catastrophic flooding destroys everything downstream. 34 generators producing 22,500 megawatts. Ship lifts raising 3,000-ton vessels 370 feet vertically. Spillways discharging millions of gallons per second. The dam's mass slowed Earth's rotation by 0.06 microseconds. The reservoir holds so much water it shifted the planet's moment of inertia. They didn't just build the largest dam. They built a structure massive enough to affect planetary physics. Engineering, reshaping geography itself, proving that construction has no limits when ambition meets precision. These 15 projects aren't predictions. They're proof that the future is already built.